Okay, 13.1. Let's look at number 2 in the homework. We're going to sketch some points. This is Z, Y, X. Our first one is 0, 5, 2. So we don't go anywhere on the x-axis. We go 5 on the y and 2 on the z. So we have our first point is 0, 5, 2. Okay, next one, 4, 0, negative 1. 4 on the x. We don't go left or right, and then we go down 1, and this is 4, 0, negative 1. Call it Q. 2, 4, 6. So we go 2 on the x-axis, we go 4 on the y-axis, and then we go 6 up. So that's 2, 4, 6. Let's call that R. And 1, negative 1, 2. Let's do that in red. We're going to go 1. Then we're going to go back on the y-axis. So 1, negative 1. And make a little box. That's right there. And then we're going to go up 2. So we're going to go up 2. So we go ahead 1 on the x, we go back 1 on the y, and then we go up 2 for the z. 1, negative 1, 2. Let's call that S. Okay. Let's look at number 6. Let's go back to black. Number 6. Let's describe what x equal 4 in R2 is. That means what is it in 2 dimensions? Well, that's just a vertical line through x equal 4. So in 2 dimensions, 1, 2, 3, 4, we're just going to get a vertical line. Now in 3 space, that means x and y and z can be anything. It's going to be a plane parallel to the yz plane through the point 4, 0, 0. So this is z, this is y, x is coming straight out at us. We're going to go 1, 2, 3, 4, and then we're going to draw kind of a plane through this point right here, and this is the YZ plane flat on the paper, and it's parallel to that. Okay. In B, we're back in R3, x equal, or y, sorry, y equal 3 is the plane parallel to the xz plane, and it's through the point 0, 3, 0. And z equal 5 is the plane parallel to the xy plane through the point 0, 0, 5. Okay, so this is going to be kind of hard to draw, but let's see if you can see it. Y equal 3, 1, 2, 3, and it's going to be parallel through this plane, and z equal 5 is going to be like that. And now, what do they both represent when you have y equal 3 and z equal 5? You get this line where they intersect, and that's right here. Where these two planes intersect. So it's the line where x can be anything. Y is 3, z is 5. parallel to the x-axis. So it follows the x-axis. Okay, let's look at number 8. Find the lengths of the sides of the triangle with 3 vertices, and then we have to decide if it's a right triangle or an isosceles triangle. So the line segment AB, find the distance between points A and B. That's just going to be the square root of the x's subtracted, which is going to be 4, and then you square them. The y is subtracted, and then you square them. And the z is subtracted, and then you square them. And that equals 3. We do the same thing for BC. Subtract the x's, square them, subtract the y's, and square them. But the x's drop out. That's 0. So that's square root of 45. And AC, the distance, is going to be the square root of 4 plus 16 plus 16. That's square root of 36, which is 6. So if I take these two sides and do 6 squared plus 3 squared, that's 45, which is this side squared. So it's a right triangle because it follows Pythagorean theorem. A squared plus b squared is c squared. So BC is the hypotenuse. So if I take AB squared plus AC squared, I get BC squared. So it's a right triangle. It's not isosceles because none of those are equal. Isosceles means 2 equal sides. Number 10. Okay, find the distance 3, 7, negative 5 from the xy plane. Well, let's graph it. That might help. It'll be hard to see, but 3, 7, negative 5. So it's down 5. Well, the xy plane is right here flat. So the distance up would be right here, and A would be 5. The distance from the YZ plane, okay, this is Z. So the YZ plane would be that distance to that plane, and that is 3. Let's try to use different colors so you can see it. C, XZ plane, the XZ plane is this way, and that's 7. D, the x-axis is here, so it would be this distance here. So I would use the Pythagorean theorem on 7 and 5. So the square root of 7 squared plus 5 squared is square root of 74. E is the distance to the y-axis, and that would be right here, and this is 3, so it'd be the square root of 3 squared plus 5 squared, which is square root of 34. And then finally F is the distance to the z-axis, and that would be let me see, let's do pink. That would be this distance here. That's the same diagonal as in the bottom of that. If we draw a right triangle, that would be the bottom. So that would be the square root of 7 squared plus 3 squared, and that's the square root of 58. So you're just using Pythagorean theorem to find those distances. Let's look at number 12. Find the equation of the sphere with center of 6, 5, negative 2, and radius square root of 7. So that would just be x minus 6 squared plus y minus 5 squared plus z plus 2 squared equals square root of 7 squared, which is 7. So there's the equation of the sphere. Describe its intersection with each of the coordinate planes. If you intersect it with the xy plane, well, that's when z is 0, so you have x minus 6 squared plus y minus 5 squared. That would make this 4, so you bring it to the other side, and that would be 3. So you get a circle with center 6, 5, radius square root of 3. If you do the intersection with the xz plane, then y equals 0. Then you get x minus 6 squared plus z plus 2 squared. If y is 0, you get 25. And then you bring the 25 on the other side, you get a negative 18. So that's impossible because this is always positive. They're both squared. And this is negative, so there's no intersection. If you do the yz plane, then x is 0. So we have y minus 5 squared plus z plus 2 squared. And this part right here would be 36. When you bring 36 to the other side, 7 minus 36 is negative. Again, there would be no intersection. So when you intersect a sphere, it's like you cut an orange. What are you going to get? You're going to get a circle in the in two-dimensional, in 2D, or R2 space. Okay, let's look at 16. 16, we get x squared plus c squared. Okay, we want to complete the square, so we put the x's together, the y's together, and the z's together. So here we're going to half of 6, we're going to add 9, so we add 9 here. Here we're going to add 4, half of 4 is 2, 2 squared is 4, half of 2 is 1, 1 squared is 1. So whatever we add to one side, we add to the other. That's giving us a perfect square. Adding these up, you get 25. So the sphere has center 3, negative 2, 1, and the radius is 5. Okay, well, I just did 15 for you. So if you look in the homework, actually this is one of your homework problems, 15. 24. Okay, we have to describe the region where x equal 10. Okay, that's a plane parallel to the YZ plane, and it passes through the point 10, 0, 0. Okay, let's see. Okay, where y is equal to 0, we're going to get all this over here. So that's the half space. We'll call it a half space. It's all points on or to the right of the XZ plane. "28. Y equals Z, so we get all the points looking like that. So we have x can be anything. Y, this is the y plane, this is the z plane. Y equals z would be on the diagonal going through space like that. And it would be the plane kind of lying on that line. So it's perpendicular to the YZ plane. And it intersects because it's coming straight out of your paper. So it's like a piece of paper on the YZ line. This is where Y equals Z. And then it's perpendicular, but it intersects the YZ plane in the line Y equals Z. Okay, let's try 36. We want the solid rectangular box in the first octant bounded by the planes x equal 1, y equal 2, z equal 3. So we want a solid rectangular box in the first octant. So the first octant is like the first quadrant. So we have x should be between 0 and 1. If it's in the first octant, that means x, y, and z are all positive. Remember, I stated that earlier in the lecture. So these equations right here should give us that box. If we take those bounds and graph that, we're going to get a solid rectangular box. Okay, so this is a good introduction to 3-space.